long beginning right now.
I'm into it.
17 seconds. Dan does it less. Hey, y'all. Welcome to the Common Good Podcast. It's a Thursday. I didn't even look today what day in May it is. I forget. You wouldn't think, I could forget.
11th?
It's May 11th. It's May 11th. Paul, good to see you. Doug Padgett.
Good to see you, Doug.
Dan's not with us today. But hey, Paul, there's a lot of things going on in this world that we should be thinking about. There's a lot of things in the world that we care about. Title 42 is being lifted on the southern border. Really big deal. We're going to do a little video on that later today. Some people don't know what that is or why that matters, but it's a big thing that's prevented people from seeking asylum in the United States. Donald Trump showed that he's an absolute and complete nightmare last night on a CNN town hall.
I didn't. Did you watch it? I didn't watch it.
It was not good, Paul. It was not good. It was the greatest hits, right? It's all the stuff he always says, but
it's all the same old grievances and
I'm going to pardon the January 6th people. We're going to use family separation, mocking the person he was found liable for sexually assaulting, the crowd cheering. Just really, there's, some upsides to our news cycle. There's some things like that. But every once in a while we say, look, we're all, as a Disney song said, we all live under the same big sky. And sometimes
it's big.
Remind ourselves of the big sky is a good thing. So having astrophysicist Paul Wallace here is good. It's also raining and gloomy today here in Minneapolis. How is it there in Decatur?
It's kind of the same. It's overcast and it was drizzling earlier, but now it's not. But it's overcast. We're going to hit about 82 today, something like that.
Summer.
We're in the 80s for the long haul now. We had a pretty cool early spring. Lots of days about 70 degrees, 72. But I think we've left the 70s behind for the next 4 or 5 months or so.
Well, hey, and your shirt, for people that are only watching or listening on the podcast, they don't get to see this gloriousness. It looks spacey, but now I'm realizing that's not a space shirt. That's like
those are flamingos.
You have a flamingo shirt. Had we coordinated, I also.
Yeah, look at that.
That's really
flamingo
really
shirt.
Great. Oh, here. Let's do that again. Let's go to Big Paul here on the screen. And oh yeah, look at that, friends. Hey, tell us where you're all coming from. Those of you that are paying attention and watching and all, and what shirt you're wearing, and if you own a flamingo shirt. I have a white shirt, like a T-shirt thing with full flamingos on it.
Do you? Yeah.
It's my vacation.
I got some swim trunks. with the exact same pattern.
Totally. Do you ever wear the shirt and the shorts together?
No, but I really should this summer. I will definitely do that at some point.
Oh, that's great. All right, so Paul, you're a pastor, a writer, a professor. Congratulations, by the way, as you said to me before we started here, on getting your grades together and being done with the academic year. Congratulations on that.
Thanks for that.
And you're an astrophysicist and a popularist. I say that in the best sense of the term, right? Like
a popularist. Oh yeah.
Like you popularize things. You talk about the sky and quantum realities and astro thises and that's in ways that not astrophysicists can understand what's happening. So a couple of big stories today that you said. Are you ready to jump right into these, or do you have some?
I'm ready. Let's go. Let's dive in.
All right, so this one I thought was kind of interesting. You'd sent this clip over. It says, continuing its run on its groundbreaking discoveries, the James Webb Space Telescope has snapped the clearest image yet of the dusty disk around a young star. And then it's got a name for this young star.
Yep, Fomalhaut. That's the Anglo version of it. It's some garbled Arabic. I don't know what, but. Fomalhaut. Yeah, it's a pretty bright star in the southern sky. We can see it here, but it stays pretty low. And it's about 25 light years away, and it is got a disk around it. So that little black spot, for those sports fans who can see the little black spot, that's just there to block out the light of the star itself, which is far smaller than a pixel on this size on this picture. So that black spot is,
I
that's
see.
not a black hole, right?
Okay.
It's there to it's an artifact of the telescope. It's there to block out the view, so we can see the dust disk around the star.
And why is this a big deal? Why are they excited? Is it just that the telescope can see this level of detail, or is there something else that's
Well,
really?
that's part of it. We've never seen anything like this before. All the disks that we've seen before. Now, first, let me back up and say that a disk around a star like this, we believe, is essentially a solar system in its proto phase. Like, it's a nascent solar system that will eventually
Wow.
coalesce into planets.
Wow.
This dust you see. So this might have been what our solar system looked like, 4.5 billion years ago or something.
Wow.
It's a young star.
Young
Young.
rising star making it good.
Yeah,
Someday going to be a solar system of its own.
yeah, it's working on it. And so
Just that
we've
great story
seen
we all rise to cheer.
we've seen discs before, but never with this kind of detail. You see these, you can kind of see at least two distinct bands of
Hmm.
so the smeared out rings are dust basically. Carbon, silicon, um, iron, whatever, little bits of dust orbiting that star. And you can see two distinct bands, almost like, our asteroid belt and our Kuiper belt. Our Kuiper belt, the asteroid belt is a bunch of rocks that orbit between Mars and Jupiter. And the Kuiper belt is a bunch of
Hmm.
ice bodies that orbit outside of Neptune.
Oh.
And Pluto's one of those. So you kind of see two bands here, and it's not necessarily an inner and outer belt like that, but it's what it looks like. So it's really just nice to see that level of structure in this dust. Normally, we just get a blur and don't see any structure in the dust at all.
One of the common features of all the stories we're going to look at is how that we're going to look at today. All of these new images and information is changing the way astrophysicists and stargazers understand what's happening up there. Is that true of this one as well? Is this a
Yeah, because it's showing
or
us something we've never seen before. So it forces us to rethink or to consider again, how are planets even formed? Where did the Earth come from? What did it, how was it built up, and that kind of thing. So yeah, it helps us to rethink more, with more detail and more nuance, how things happen in the universe and where we came from.
really,
It's a
really
lovely
quite?
picture. Wow,
Yeah.
I love that.
So yeah. Okay. So as I do a lot when we look at these pictures, I like a little help on knowing: is this an artist uh, uh, rendered thing, or have they done something to this photo, as far as you can tell, to make it seem so
No, this
visually
is
attractive to us?
no. This is. I mean, it's certainly processed to bring out certain details, but it's an actual image of an infrared image. So it's infrared, which means this light is not light we could see if we were just out there staring at this thing.
Sure.
Our eyes wouldn't be sensitive to it, but it is real light. It's totally real light. It's just that our eyes aren't
Good
tuned
point.
to see it.
Good point. Good point.
Um,
It's real light that can be seen by other detectors than
right,
our
exactly. And
eyes.
if we had infrared sensitive eyes, that's what we would see.
You know, just considering that, I know this isn't the biology podcast today, but boy, that would have been an upgrade that God Creator could have considered. Right? Was sort of
Yeah,
optical and infrared. Like, boy,
yeah,
wouldn't that have been like at night?
yeah.
What an upgrade! How
Or,
come?
or or if we had a switch on the sides of our heads and we could do, infrared click, and then we could see infrared, and then visible
Totally.
click, we could see visible. Yeah, that
You
that
know,
would be uh, that would be awesome.
when we talk to the biologists, they're always reminding us that evolution has some intention sort of behind it for the flourishing of the species that's evolving. This stuff, and it seems like evolution should have saw this one coming. That the infrared switchover would have been great, because as
Well, do
soon
you
as
know
you
what? I mean, the reason it can't do that,
okay, all
it
right,
can't do that because
you tell
our
me why.
atmosphere to be, it's number one, it's breathable, which is good for us.
Okay,
Number two, it protects us from all the nasty ultraviolet and X-rays and gamma rays and solar wind and so forth that's out there. But our atmosphere only allows certain wavelengths of light to come to the surface.
Okay, so
it's like it's got a little window, and it only lets the wavelengths in that little narrow window down onto the surface of the Earth. Everything else, it doesn't. It's opaque too. So it turns out, of course, that it allows in exactly the light that we can see.
Here we go again. How in the world does an atmosphere sort out light waves sizes to keep them out? What
it all has to do with the way the nitrogen and oxygen, CO2, and so forth, how they respond to different wavelengths of light.
Incredible.
And it turns out that our atmosphere allows in Roy G. Biv.
Well, that's great because that's the same colors that I have on the lights in my little studio. So
How about that?
Really great.
So,
wow, what a treat.
So of course, so we evolved so our eyes would be sensitive to that.
I see what you're saying. So we wouldn't have the kind of eyes that could see this infrared. But when somebody puts in those little infrared goggles, like the night scope goggles, isn't that infrared? Isn't that infrared?
No, it is definitely infrared. There's infrared light all around us.
Okay, so we do have infrared light rolling around inside of our atmospheric bubble here.
Yes, we do, but we have more visible because the sun allows the atmosphere allows visible light in. We have more visible light down here than we do infrared.
Do any animals see infrared light? Is that a thing?
I bet that some do, at least a little bit deeper into the infrared than we do, but not radically different. I mean, they might see, a little bit deeper into the ultraviolet or a little bit deeper into the into the infrared, but it's not like they have infrared vision and that's it. No, all creatures' eyes are sensitive to visible light. Mostly.
Well, yeah. I mean, I'm just looking for one that has both. That's just as the turbo version of their eyes. They can click over to the other. Just always considering what human biological upgrades could mean. And I don't know. Sure. Maybe we'll come up with some insert at some point that'll go into an eye or a contact
someday.
Image. I don't know what we do with that. But
we'll find something to do with it.
Yeah. Exactly what I was thinking. We'll probably come up with something.
Some diabolical, some crazy thing.
Look at that. That's a funny little image. Of the other stories that you sent, which one do you want to talk about next? Do you have a preference?
Let's see. What else did I send? I sent.
You sent this one about the.
Oh yeah, that's
wobbly,
good.
The wobbly moons of Mars. I mean, holy moly!
That picture of Deimos there looks like a butt, doesn't it?
Yeah. Okay. So here's what I found interesting about this particular story. This image that we're looking at feels like an artist rendition, but you can tell me, is a moon object that is orbiting Mars.
Mm-hmm.
Is that right? Okay.
Mm-hmm.
And the way the headline reads, which is also what's in the story, is that the Emirates Mars missions Hope probe. So I was caught by that because I guess I didn't know that the United Arab Emirates also has a version of NASA, and they're working their own deal from the UAE.
Yeah, they are.
I'm a little. I didn't think they didn't. I just never thought about. I mean, even on all the International Space Station stuff, hear a little bit about China. Certainly hear about Russia, the U.S.,
Canada.
Of course. Oh, nope, didn't have Canada in my list.
Didn't?
No.
Yeah. Well, yeah. And ESA, the European Space Agency.
See, I thought it was all like European space, like they kind of all got clumped in. But then the UAE and others also have their own missions going on. That's just kind of great, actually.
It's kind of great. Yeah, I thought it was really cool too. And I'm not sure what sort of class of mission this would be equivalent to, and for NASA, for example.
What does that mean?
I mean, there's different kinds of missions, different levels, different levels of missions have different budgets. Depending on how quickly and how cheaply they want to do it, that kind of thing. I can't remember all the classes, but there's a lot of them.
Uh,
And but anyway, so yeah, and so you asked about that picture, and I can't tell from that picture whether it's a composite or whether it's an actual picture. My guess is it's a composite, but they got the sun angle right.
okay.
So
Interesting.
so that makes me think it might not be, but I suspect that it's a composite image. It's not. I mean, I've seen real pictures of the Earth and the Earth's moon that looks very similar to
Yeah,
that.
right, right. It's in that frame.
And they seem kind of surreal like that, but it's a real
Totally.
picture. So this could be a real photograph for all I know.
All right. So what's cool about this is that the UAE in their telescope that they shot up there, their satellite,
Yep.
unlike the one from NASA and from other groups that are very close to the surface of Mars because they want to work on the surface, they set theirs apparently far away so they
Right.
can sort of get the big picture of it all,
Right.
which
Right.
is also kind of great that like these agencies and international agreements are figuring out, who's going to look at what. Kind of
Right.
great.
Hey, we can cooperate.
As it turns out, yeah, if we're just staring at rocks floating around in
Yeah.
space.
Yeah. If it's completely unrelated to human, immediate human needs.
Um, the uh, the fact that this thing is sitting out further and looking at Mars from the outside, from what the article said, they'd sort of completed the mission of the Emirates Mars mission Hope,
Yep.
got what they wanted, and then they're like, we still got this satellite up there. Or
Yeah.
is this satellite or
This
telescope?
the,
What is it?
the oh it's yeah it's a satellite.
The probe. Okay,
Yeah,
so satellite.
with
So we've
with
still
with, with cameras on board and so forth.
so we've still got this I Spy satellite up there. The UAE is saying we might as well like start whipping that thing around. Look at a few other
Yeah.
things, and then they discovered this. I just love everything about that.
Yep.
Right, that they're up there. They pick another vantage point. They're done with their mission, and then they just start looking around.
Yes.
And they
Start looking around. Yep.
and then they discover something that seemed to be quite important. From this headline, it says the surprising results from this I Spy spacecraft call the origin of the smaller moons into question. So now they're
Yeah. At
thinking
least this one.
maybe.
There's two small moons, and for years in astronomy, I have taught, and everybody who's ever taught introductory astronomy has taught that we suspect that these two moons, Phobos and Deimos, Fear and Panic. Those are the two names of the two moons, Fear and Panic.
Nice.
Phobos and Deimos were captured asteroids
Yes.
because Mars is just inside the asteroid belt, and the gravity of Mars could capture, it could capture asteroids. But it turns out that Deimos, which is the one you see here, is probably not a captured asteroid. This is what the UAE learned from their mission, looking at the light reflecting off of this moon. They split it up into a spectrum
Hmm.
and discovered that there's a lot of so-called basalt. You ever take geology?
Nope.
Well,
Well, yes,
basalt
but
is
I
a
don't
kind
remember
of
any of it.
a basalt is kind of rock that comes from volcanoes. Okay,
Okay.
so there's a lot of basalt in this moon, and no asteroid would ever have a volcano on it.
Okay. So of the things we can't know, that's not one of them. We
This
know
is
that asteroids don't have volcanoes.
We know this. Asteroids do not have volcanoes.
Is that going to show up on one of your pop quizzes? True or
Absolutely.
false? Volcanoes,
Yep.
asteroids can have volcanoes.
So when I give the quiz later, there's no excuse for not knowing the answer.
Okay, so no, so that's telling them this is made up of something that has its origins from
Or
something
that
other
was
than
volcanic at some point. And Mars
what?
was some billions of years ago was super volcanic, like super duper
Okay,
volcanoes all over the place. And there's still, there's a bunch of them left. They're not active anymore, but they're huge. These are volcanoes that are, the size of Texas 20 miles high and the size of Texas. So,
So what they're
these are
thinking, somewhere this thing just spit out some kind of
could
lava
have come
rock,
from
and it shot up so high it got outside
yeah,
the.
yes, due to a collision with, in the past. Remember that picture of the star with the dust around it we just talked
Yes.
about?
Yes.
Over time, that dust would, because of gravity, it would collect, it would build up into these certain, it would coalesce into larger clumps because
Yes.
of gravity. And once that process starts, it speeds up because the more massive the object gets, the more it pulls more stuff in. So in the past, early in their, put it this way, early in their lives, solar systems are always very violent places with rocks colliding and all kinds of stuff going on like that. And so it's believed now that Deimos here was probably created in one of these collisions, kind of like we think the moon of Earth was created a
How do
long
you
time
like
ago.
that?
Yeah. So
That,
at least Deimos, we think, was not a captured asteroid.
I mean, it's so much cooler to think that Mars volcano spit out some gigantic
Yeah.
lava rock. The level
But
of force it would take, obviously, for
no,
that
no,
to.
but this would be due to a collision.
What?
Due to a collision, like in the super deep past. This would be due not to a volcano spitting it up, but
Okay.
to a collision of an object with Mars,
I
throwing
see.
junk up into the air.
Well, that's even more
And
impressive. Something hit
yeah,
Mars so hard that
yeah,
it bounced something the size of this moon
yeah,
off the surface of Mars,
yeah,
up out of the gravitational pull, where now it's
yeah,
moon orbiting.
yeah. And most of the
All right,
stuff
that
that
just
got
seems crazy.
most of the stuff that got ejected would have either fallen down back onto Mars or been thrown out into space forever. But not this.
Okay,
That's the theory.
so
We don't
so
know, but that's what the evidence is leading us to
fair
think.
enough. And this theory
Yep.
is one based on the belief that the way gravity works, something can hit the moon, hit a planet like Mars or the Earth hard
Yep.
enough to cause a ricochet or a
Yeah.
something
Or
else.
it would also
That
have to hit
just
it.
seems unthinkable.
It would also have to hit it not head on, but like a glancing blow to the.
Oh yeah,
You
like
see what I'm
knocked it
saying?
off. Yeah, like
To give
chipped
it
it off.
some to give it some motion around the planet. It wouldn't have been a bullseye head on collision. It
I
would have been
see.
a glancing thing.
I see. How
Yeah.
big is this moon?
I don't know the answer to that, but it's almost spherical, but not quite. I'd probably guess maybe 10 miles across or something.
So again, it chipped off a 10-mile across piece
Yeah.
of rock.
Chipped it off.
Chipped it off. Chip off the old Mars. Hey, I sent you this article the other day about the sorry, I'm trying to get the camera right.
Sorry.
Having to do it all without Dan here today. It's hard. It's hard without Dan. Everybody knows life's hard without a Dan around.
I know. It is tough.
And it was talking about the development of Mars. I think it was PBS or some, one of those little info videos. It was really cool, I thought, about their description of just how liquid Mars was, and some big asteroid hit a lake, and that the makeup of Mars is so similar to Earth, which is what helped me. And you've probably been saying this for years, and I wasn't getting it, that paying attention to Mars is a way of paying attention to what could be happening on Earth, that there's enough similarity in the like the geological makeup that it tells us something about what Earth might be like. Is that right?
But
fair?
yeah, that's true. And Mars would be a couple billion years ahead of Earth on the schedule.
Yeah.
And the reason why it's ahead is because it's smaller and it loses heat more. It loses heat more quickly. Like if you take two potatoes out of the oven, a big potato and a small potato, the small potato is going to cool off quicker than the big one. So Mars cooled off more quickly than the Earth is cooling off. Follow me?
Yeah, I am.
And so it's that cooling And it's that heat and the loss of the heat that has driven Mars's climate and atmosphere over the years. And so, in that sense, you can sort of look at Mars and sort of see what the Earth may eventually be like. We're just a couple billion years behind as far as a lot of that goes. Yeah.
Hey, I'm noticing people are saying that my volume is low on YouTube and so on. So I don't know why. I'm turning it up. I don't know if it's louder for you, louder for anybody else. Let me know.
I can hear you fine.
You've been able to hear me fine the whole time, I'm guessing, huh?
Oh, yeah. No problem.
Okay.
No problem at all.
Yeah. Well, poor Kimberly and Mike and Jim and Yabbits are like, it's having some trouble. All right. So that is, that makes Mars more interesting to me, at least, and all the work we're doing and all the looking up there is, this could tell us something about our own experience here on this planet.
Right. Especially when it comes to water. Like it's believed that Mars used to have a huge ocean, mostly in its northern hemisphere. And now it doesn't. It doesn't anymore.
And that's not being blamed on big corporations, right? It wasn't. Or do you think there were like big corporations on Mars at one time?
There probably were, and they're the ones who screwed it up.
Yeah, I shouldn't be trite about that. Our own climate change is caused by human interaction, and there's also, like, I don't know, just geological things that are going on that cause these kinds of impacts and changes.
It's also good to remember that Mars is much further away from the sun. That makes it a little different and makes it colder. Also, its atmosphere is not nearly as robust as ours. So being on Mars is really dangerous because of all the radiation, and mostly because of the radiation that you'd get exposed to.
Now, Kimberly is asking, is after everything got real cold there, is that when they came here? Is that when the Martians arrived? Or what was it, in your opinion, as an astrophysicist,
that's where we came from? We came from Mars. We were there first, and almost died, but a few of them made it down here to Earth.
Adam and Eve, those two.
Yeah, that's right. That was their names.
It was the pair. Hey,
it was the pair.
So you were saying Mars, it was ahead on the timeline of cooling off by billions of years. But is Mars essentially, did it come into being essentially the same time the Earth came into formation?
Yeah, the whole solar system really did, including the sun and the asteroids and Pluto and all the rest. All were formed at about the same time. And we can sort of look at that star again, Fomalhaut, the star that we were looking at with the dust around it. I mean, that's a star that's fairly new, fairly young, maybe 50 million years old or something, which is young in astronomy land. And everything that you see around it is being formed into a solar system. And it's all formed at about the same time.
I see. Yep.
So everything in our solar system, we believe, came into be. Basically the whole thing formed at one time. Of course, at one time it took 100 million years to happen.
That's what I was going to ask you. Yeah. So, but in space timekeeping,
on the 4 billion year time scale we're talking about, it all happened roughly at the same time.
Roughly at the same time.
Yep.
All right, we've got one more that we haven't yet talked about. There's a second ring around the far out dwarf planet Quasar.
Quasar, you did it. You said it right.
That was just an accident. That's just blind squirrel business right there. Adding to the mystery of how this world hosts rings at such wide orbits.
Yeah, it's got rings.
Why is this a big deal?
Number one, it's weird for such a small body to have rings. Normally, this the really big honkers like Jupiter, Saturn, Uranus, and Neptune. They all have rings. Earth doesn't have rings. Mars doesn't have rings. Venus doesn't. Mercury, all the inner planets, the small ones, don't have rings
because they're too small.
The gravity is not strong enough to basically do what has to happen. So number one, it's kind of weird to think that a body such as Quasar, which is a little smaller than Pluto, really small.
I see.
Yeah. Okay. Why it's got rings in the first place.
Who put a ring on it? That's the question that has been
Who
being
put a
asked.
ring on it?
Yeah.
That's what I'm saying.
And
So,
what does this tell us? Because this now that there's a second ring around this small
well,
planet.
there's actually two more layers of mystery here. Number one is, how did the ring even get there in the first place? Because it's such a small little body. Number two is,
Adorable.
there's two rings, okay, which is a big surprise.
Mm-hmm.
And number three, which is really the kicker, and this is sort of nerd stuff at this point,
Well, please.
is how can those rings be stable where they are? They shouldn't be stable. There are certain distances outside of which rings should not exist. It's a gravity thing. It's a Newton's laws thing.
Sure.
That
Yeah, I can
says
see
that
that. But
outside of a certain distance, the orbit should be so slow that the rings really shouldn't really hold together. They should kind of either dissipate out into space or coalesce into a moon.
so in my life, when there's mysteries that I don't understand, the people I hang around with, we just go, I don't know. I have no idea. Like, I don't even have a guess on how something happens, right? I
like
don't know.
like
It's a
how's your
mystery.
phone work, right?
I don't
I
know.
don't
I
know.
don't know. It's a mystery. Yeah. How would I know? My guess is astrophysicists aren't like, boy, here's a real stumper. There's rings around a small planet, and they're further away than we thought rings could form. So who knows? Someone's
Yeah,
got a
right.
theory, right?
Yeah.
So
Yeah. It's the. I mean, that's the who knows part. I mean, the wonder part is there. They're curious. They want to find out, and they're like, why? But they actually do something about it
who
when
do you have an idea of what current thinking is
no,
about why
there's
these
no.
rings?
So far as I know, there's no understanding of where this might have come from. We're really at a pretty early stage on this. I've got this. We've got this physics astronomy student, astrophysics student. Actually, her name is Kara, and she does the bulletin boards around the observatory here. And she did a bulletin board about this very thing. So I'm really up to date on it because she did her research. And right now there's no real working theory as to why this is.
Because the Jim is asking in the uh, YouTube chat, does Earth have rings? And as you
No,
said earlier, it doesn't. And the reason we think it doesn't is because it's just too small.
yeah,
Only the big ones have enough gravitational effects to
yeah.
put things into ring. Well, that's not true.
I think
So if
it's
that's not
possible.
true,
It's possible for Earth to have rings. It's possible for Venus to have rings. It's just really it's super unlikely. Put it that
okay,
way.
it's not violating some
No, it could
formula of
happen.
gravity.
It's just the smaller the body
I
is,
see.
the more unlikely it is to have rings.
So maybe our explanation about why Earth doesn't have rings is partly size, but according to this, because of this little planet that's not even really considered one of the real planets, like a little
Nope.
Pluto planet,
The dwarf
um,
planet, yeah.
it gets to have rings.
It gets to
Uh,
have two, at least two.
two, and it could share one. If you have two, share one. That philosophy of life. That is
Oh,
that is curious to me that that there's another reason why rings form that's not simply size and gravitational pull related.
yeah, right. It's either that or that Qualwar really threaded the needle and got the super unlikely, But still, it's not clear how the rings can exist outside of this limit. Um,
Is there
oh, and
something else there we're not seeing? Is there something these rings are around that we don't? Is there an
well,
invisible? Is
I
there
need to warn
invisible
you that
plant?
this is not a photograph. This is an artist's, one of these artists,
See again.
things.
Could,
Yeah, we've never actually taken a photograph of the rings. How
so
do you like
remind
that?
us again. Then how do we know the rings are there? What do they?
Ah, grasshopper. Now we're getting somewhere.
Okay.
What we do is what
How
we
do we
do
know?
is we basically in the field. So if you're looking at Qualwar and you're looking at the field around it, Qualwar is actually passing in front of the distant stars. Okay, and as it goes, it carries its rings with it. And when the rings block the starlight from the distant stars, the light of the stars dips a little bit.
Okay, it's like it's orbiting the star the way Earth would.
It's Quaoar is orbiting the sun, so basically, imagine the stars as like a distant backdrop
Gotcha.
that don't
I gotcha.
move, and Quaoar is moving in front of those distant objects.
There it is.
And so when the ring gets passes over a star, the light from that star dips just a little bit.
Okay.
And we can detect that.
The dip
In the starlight from the distant stars behind Quaoar. We can detect that dip in the starlight, and we can predict if the ring is there, or which stars are going to be blocked out when, and it happens just as basically we can look at the pattern of starlight dropping a little bit in the distant stars to figure out where the rings are. Amazing.
Is it possible that there's something else that's causing this dip, and it's not rings? Is that one?
Not really. No. Okay. No. There's no other possible explanation for it. Maybe tomorrow somebody will come up with one, but right now there's no other. I mean, we've seen this too. This is how we discovered the rings of, Neptune, for example. We discovered them the same way.
Mm-hmm.
And with exactly the same kind of pattern,
Yeah.
So
there's rings.
There's rings for sure.
And this is the wonderful thing about this branch of science and the others is there's so much we know, like stuff like that, which is almost mind bending about what can be known and how we figure stuff out by computer, data that's coming in, because dips in light is also not something we're seeing with our eyes, right? It's something that's being detected on a sensor somewhere,
and we're not seeing it with our eyes on the video screen. It's just a little data point that dips. We see a curve. That's all we see.
In a data point.
Yeah.
So that's numbers. Amazing. We can do this and see these numbers and interpret them and extrapolate them. Mm-hmm. And at the same time, there's so much we don't know about this stuff.
Yeah.
Just so very much that's unknown about all this.
And the nice thing about science is that the way it's set up and the way it operates is that you can, if you keep banging your head against the wall, you can figure it out. And a lot of things are just not that way.
That's right. That's right.
I mean, really, let's be frank, the meaning of life, the problem of evil, what I'm saying? It's like,
it's like the human stuff. The human stuff is a little more.
I have no damn idea, but I can tell you that there's rings around this little
than the spacey stuff. Yeah, that's right.
Yeah.
All right. So I think there's one more. Scientists say they found more moons with oceans in the solar system. Now, moons have oceans?
I did not read this one, but I can tell you a little bit about it nonetheless.
Please do. Yes.
Yeah.
I did not know
moon.
Okay.
Oh yeah. The one that's...
Again, I just thought, and before you do this explanation, I want you to explain why I think this is such a big deal. The hunt for water has seemed like this big thing we have been wondering about. Like, I just thought water in space, if they find that, that's going to be a deal. Then come to find out, wow, not frozen water. We all know that. Most things out there are just a bunch of frozen water. Like, water's all over the place out there in different forms. And now there's I don't know, lakes and oceans on moons. So it's had, I don't know why I got it in my head, or as a kid hearing that, if we find water, then you got life. And if you've got life, baby, that answers the questions.
There you go.
Apparently that was never what the storyline was, even though that's what I had in my head. So now to hear that moons even have water.
Yeah, but there is a twist, which you won't be surprised. There's always a twist, right? The headlines are never quite. Okay. I mean, that makes you think that there's these moons with nice big ocean. I mean, we see the oceans, right? You imagine being at the beach. Look, there's an ocean.
Mm-hmm.
It's not like that. think of it this way. Imagine, like at the North Pole, how there's no land up there, but there's a big ice
Right.
cap
From what I've been told, yes.
covering the ocean, right? Right, right. Yeah, I've
Okay.
not been there myself personally, but I've been told by people I
That's right.
trust,
That's right.
which is why we believe most things we believe, by the way. Um, Somebody I trust told me that up at the North Pole, there's, no land. There's just floating ice. You can go walk on the ice, but there's no land proper.
Okay. Yeah.
So what I want you to do is imagine a moon that's entirely that way. That's just one big solid ice block, but with water underneath the ice. The ice may be a kilometer thick, but underneath that, there would be liquid water.
Okay.
That's what we have. When they say oceans, that's what they're talking about.
Somewhere
Oceans,
between whatever the core of the moon is and the surface of ice, there's
yeah.
liquid
So basically,
H2O.
this is a moon with an solid ice crust with liquid water as the next layer down.
Huh.
And some of these moons, like Europa, which is a big moon of Jupiter, has geysers and so forth. Has places where that water is pushing up through the surface, kind of like we have volcanoes here. They're basically water volcanoes or geysers,
A big water
and
park.
so and we've taken images of these geysers, and they're definitely liquid water. And so there's definitely liquid water underneath these crusty this ice crust, basically.
Hmm. Well, Jim asks, I think, an insightful question. What's the origin of water out there and here? Just hydrogen and oxygen coming together in a certain
Yep.
level, and
Yep, the hydrogen was formed, most of it in the universe was formed pretty much very soon after the Big Bang. So all the
okay,
hydrogen in your body, all the hydrogen atoms in your body have been around for 13.8 billion years.
super old.
Yeah, super
Uh,
old. The oxygens are more recent. The oxygen was all formed inside of stars. Um, and then if you have a situation near a star where a star goes supernova or just near a particularly bright star with a lot of UV light, these conditions can cause oxygen and hydrogen to bond. So that's where it came from.
as far as
Some
we know, is there water on our moon?
no. There may be some ice. There's no liquid water. There may be some ice on our moon, yes, but not. It's only at the poles and only in these really hard to where the sunlight doesn't hit it. Basically,
Because it would
um,
evaporate. Is that
it would
why the
evaporate.
sun?
It would sublimate is the physics word when it goes straight from solid to gas, like dry ice does. Here on
Oh, sure.
you
Hmm.
know it goes straight from solid to gas. That's what it would do on the moon if the sunlight were to hit it. It would sublimate and go into gas and escape into space.
I
But yeah,
see. Because
there's a little bit. We think there's a little bit of ice on the surface of the moon.
and again, that's the difference. There is that to Earth is that we have an atmosphere, and the atmosphere keeps that puts a lid on losing all that water,
Right.
right?
It's really the gravity. Yeah, but yeah, it's really the gravity that keeps the atmosphere tied to our Earth. That would
And
keep
that keeps
water vapor.
the flow. Yeah, the water evaporates, but then gets trapped in the atmosphere, and then
Right. Right.
congeals back together. Probably not the right word, and then gets heavy enough, and then the
Right.
floating water again, just call
Yeah.
it floating water. The water then
Yeah.
floats because of airlift, and then gets
Yeah.
heavy enough to fall, and it stays in the same cycle. And the amount
Gets
of
cooler.
water on the planet is the
Yeah.
same all the time. Is that true? The amount of water that we have on our planet
Yeah. It's
doesn't
fixed.
change?
It's fixed. We might get a little bit out of volcanoes, but not much.
Which
But
is
it's
also
it's
trippy when you start thinking about droughts and other things. That like it's not that there's not enough water, enough water.
right.
It's just distributed in a way that's
Right.
moving around this
Yep.
entire
Yeah. I
planet.
once saw this great picture of of the Earth as a sphere, and then beside it, a sphere of water that basically indicated all the water that we have ever had and will ever have. It was it was like the size of the diameter of maybe the United States. It's a ball of water, and that's it. That's all we're ever going to get. It just gets redistributed over time.
Wow. Can we make water?
Yeah, but it's not. It costs a lot to make it in
Yeah.
bulk. It doesn't cost a lot to
Costs a lot to make an
make.
F-16 too, and we seem to have no problem making a whole bunch of those and flying them around.
I mean, it's not expensive to make, but it's expensive and takes a long time to make enough of it to make a difference. Like we can bond two hydrogens and an oxygen very easily, but we have to do that 10 to the 23rd times to get this much water.
Okay.
You know what I'm saying? It's
like water's not very efficient to be made.
Yeah.
Even though
right.
I don't know,
Right.
space or whatever made it. How soon was water formed here on this planet? Was that early? Is this
I don't know.
Well, we always turn to geology.
I don't know the answer to that. Yeah.
And these
But,
moons and so on, they must. I mean, water must have been there right from the start on those.
Oh yeah,
things,
water.
right?
The whole universe has water in it. I mean, we see water in gas clouds around distant stars. I mean, we see water vapor. We see H2O. We see the molecule almost everywhere. Yeah.
Wow.
Am
I the only one who was perplexed by that? That I thought that water was a real earthy thing, and that. Do you have any idea why I was so misinformed? Why I was so misinformed about that?
I don't know, but I mean, what I'm talking about here is H2O. I'm not talking about oceans.
Yeah, no, I'm
like big blue oceans. Yeah.
Literally,
H2O is
yeah. That's what I thought. I just all the things. It's not. I've realized.
It's a little uncommon. I mean, there's only one part per 10 trillion or something, but
Sure.
There's enough of it out there that we can easily detect it. Yeah.
Well, I'd love to know in the chat from Yabbits and Kimberly and Jim and Mike and all the others here if they also thought that water.
Well, it's just so important.
Was kind of earthly, and we found it somewhere else, and we got a place like Earth, and here we go.
It's just so important. Yeah, it's just so important to us.
Yes.
We think, we're unique. Maybe water is unique down here too.
And if we find it elsewhere, then maybe the other things that are derivative of water are needing water.
Yeah. I mean, all those every comet you ever see, every comet in the orbits the sun, and there's probably 1 trillion of them, is made almost entirely of water, ice water. I mean, it's ice, but it's still H2O.
Yeah, sure. Yeah. Again, just guess I didn't know that. But again, finding liquid is the thing. Water.
Yeah, we think liquid is the thing.
H2O in the form of liquid. That's why this previous story we had about oceans was a big deal, because it's like, well, it's ice. We expect that, but then under it, it's flowing. It's liquid.
Yeah.
And it's the liquid part that maybe if I just insert water for liquid water.
Yeah,
it solves the dilemma.
Yeah, liquid water is much less common than plain old H2O, and these you're not alone there, Doug.
Yeah, like one guy, me and Jim.
Water you buddies. And Jim. Yeah. So these moons must have some sort of internal heat source. They're not completely cooled off from the heat of formation, and that's what makes it warm enough to have liquid down there.
Okay, that's interesting. Yes, we know our planet has a mantle heat thing in the center.
Right.
Larger than Mars, I heard in this little Mars video that I watched.
True.
And so that's partly why Mars cooled faster, is because the size of, whatever the core and so on.
Yeah.
So these moons must have something that's keeping it. How do they know these moons have water underneath short of the ones where it's spurting out?
Two reasons. One is sort of theoretical and one is observational. The theoretical one is that ice floats. We know that ice is less dense than liquid water.
Yep. And
whenever we have ice on the Earth, there's going to be liquid beneath it. Think of lakes.
Yeah, for sure.
I've heard that up north that ice forms on lakes.
I walk on water regularly here.
Down here in Georgia, that's a rumor. No, I've seen the ice on the edges of lakes and ponds down
Yeah.
here, but never.
But have you ever seen it
I
thick
don't.
enough to drive a car out there?
No,
Or
I've never seen it thick enough to walk on.
you
Never.
got to come here in the wintertime. It'll blow your
I
mind. And then
know.
you go out there with a auger and you cut a
Yeah.
big hole in it for ice fishing, and you're like, oh, it's a foot deep or 2 feet deep,
Yeah.
like really, really thick ice. In fact, I walk on a lake right near here, and it has a little part where the water's going out of the lake, so
Yeah.
going to the next lake, a little spring, a little
Yeah.
flow out, and that part doesn't freeze. So there's ducks
Right.
floating in there. So you're walking on the frozen lake right up to the edge, and then looking 6 feet over, and there are the ducks swimming. And you're not on land looking at the ducks swimming. You're on the
Right.
frozen water,
That's
and
that's
like it just
nuts.
hits a spot and then freezes right there. And when it freezes there, it freezes thick enough that you can walk and ride your bike. And, people are like, "Hey, be careful! It's open water there. When you're
Yeah.
walking or riding. I ride my fat tire bike out there. People will be like, "Yeah, be careful! There's water in case you didn't see it." I'm like, "Yep, okay, got it." Like just as normal. Just walking on frozen. And people that live in warm climates, honestly, they're a snowball is one thing. Walking on water,
Yeah.
I've been with many people driving them around, here in Minnesota around these lakes and being like, oh yeah, no, there's people walking out there, and the look on their faces. My friend Colby from San Diego was just like, what?
Yeah.
You
I need to.
can
I need to. I need to come up there in January
you
and see
can
this. Oh,
walk on it like
I
every
should let
day for
I should let
months.
you. I should let you and our readers know. Our listeners know something about water that makes that is really unusual about water. Is really. I mean, I don't. There may be other molecules that do this as well, but typically the solid phase of a certain material is heavier than the liquid phase of that same material.
Yes,
So,
right.
right, but that's not true for ice. Ice floats, which is really weird.
What
That
floats your ice, Paul?
ice expands when water becomes ice. It expands, and in
And there's
virtually
air in
every
there.
other material, when a material freezes, it contracts. It doesn't expand, and so it's sink. Ice should sink, but it doesn't. It
Does the
floats, which is
opposite.
really weird. Yeah.
So when it gets solid, it gets lighter. Is
It
it
gets
because there's
less.
air?
It expands, and so it becomes less dense.
Expands.
It
The
expands.
molecules of the water molecules expand. So
Yeah.
there's then
So
more
if you've got a
air.
pound of water and a pound of ice, the pound of
Yeah.
ice takes up more volume,
Okay.
and
Oh
so
yeah,
it
yeah. Because
floats.
I've put frozen water, like a water bottle, in a freezer, and it
Right.
gets bigger
It'll
and
break.
cracks it.
It'll break your
It'll
bottle. Yeah.
break it
Right,
open.
because it
What?
expands, which is unusual. Usually, when you cool things down, they
They
contract. They don't expand.
Yes, I mean, you heat something up, the molecules start moving faster, and
Exactly. It expands. Yep.
why is water peculiar like that? What's it? Do we know? Is there?
It's I can't remember the details of it, but it has to do with just the H2O molecule and how they behave with each other. I think it's got something to do with the fact that they're slightly polarized. I can't remember the exact details, but it is an unusual thing that our lives depend on that
Yeah, okay.
basically.
Yabitz just said this in the chat from Marietta, Georgia, by the way. If water did not expand into ice, life would be impossible.
Imagine life
Why is that?
in lakes. If ice formed on the bottom,
Yeah,
fish wouldn't be
right.
able to survive
Well,
because
yeah.
what fish do in the winter is they feed off the bottom.
Mm-hmm.
But
They're
if
the
ice
bottom
formed on the
feeders.
bottom, it would cover up all the stuff they need to live. And so life could not have existed in fresh in anything that froze over. Life could not have existed on. Life may still exist in the oceans these days, but it wouldn't have made it very far onto
So I
land.
thought like when I'm on a lake and we ice fish, which I
Yeah.
do for recreation and watch other people because it's about the same. Ice fishing and watching someone ice fish is almost the same thing, uh, right? But less work.
Mm.
So you cut a hole with
Hmm.
a like an auger. So if people don't know, like somebody starts up a like a chainsaw thing and then points that auger down blasts out a big hole wide
Yeah.
enough, and you put your. And I thought, well, here's why: because it doesn't freeze all the way down. Is that I didn't think ice was floating. Of course it does. I've seen ice cubes. But I thought in the
Yeah.
lake, what was happening was the air temperature on the top of the water was cold enough that it got to 32
Yeah.
degrees and froze. But then down deeper, it wasn't impacted by the air and
Oh,
stayed liquid. That's what I
like,
thought was happening.
yeah.
Not that
Yeah.
it was lakes were floating the ice, but that
Right.
the freezing was starting closer to the air and going down.
The
That's
water's
not
actually cooler. It's
that's
actually
not,
cooler the further down you go. I mean, you've dived
but it's
into a
not
lake
freezing.
before.
But
No, it's
yeah,
not
but
freezing. But even if the ice, the
it's
even if you
cooler
were to,
when the air is warm in the summer for sure. You get
yeah,
deeper in the water and you're like, ooh, there's a cold spot.
I think
Um,
that's still true in the winter. I think it's still colder as you go towards the bottom.
but it doesn't get as cold as it is on
No,
the top where it's frozen
right,
in the
right,
winter. It's
right.
funny. Okay, so is it
And if
floating?
ice were to form at the bottom, it would float. It would rise to the top.
See, this just fascinating.
It's a crazy world. Someone ought to sell tickets.
Hey, did you just make that up or is that material?
No,
Did you just
that
come up
came
with
from
that?
that came from Raising Arizona. Remember that movie, Raising
Yeah,
Arizona? Did you ever see it?
yeah. I had
Yeah.
who's that act
Nicolas Cage.
Nicholas Cage, an
Is
early Nicholas Cage. Yeah,
yeah, yeah,
yeah.
and one of the first Coen Brothers movies.
The only line I remember from that movie, now it's going to be this one, is you have to have a license to drive a car and something about a pet, but any moron can have a kid.
Any moron can have a kid.
That's good. Life's fascinating. Someone should sell tickets. Is that what you said? Life's fascinating.
It's a crazy world. Someone ought to sell tickets.
Yeah.
Something like that. I'll
Okay.
have to go find the
We
exact quote,
we
but something
we
like that.
won't get into this now, but Mike raises a really great question. Paul, I was never comfortable with the Big Bang Theory. Maybe one day we'll replace it with a more organic process of reproduction, renewal, and ongoing growing of the universe. Let's chat about that sometime. I think that's an interesting,
Great topic.
as opposed to sort of a bang is starting something that I think Mike, and he could write more on this or send us a little voice memo or something, a video about it if you want to, Mike, please do that. What that question really is getting at, but I find that to be quite fascinating. So
Yeah, that'd be a great thing to talk about next time.
all right, Paul, well, congratulations on another great episode and finishing your grading early, and I hope you get out in that nice muggy forming air and
It
right
looks
there,
clearer now, but I'm sure it's
right
still
there in
I'm
Georgia.
sure it's
Hey,
still muggy.
what birds are you seeing these days down there in Georgia now that they're
Hey
making
man,
their
we
way
just
back?
came through the peak of migration. Just came through,
Wow.
boom, and I hadn't gotten out in the last few days. My son graduated from college last weekend, so that took all the birding off of the
Okay.
map. But I did see a few birds come through the college here. I'm trying to get 100 species on campus, and
Really?
yeah, I've got
Like,
92 right now.
you mean you're trying to document them, or you're doing something
I'm
to
trying
attract
to
them?
basically document. I'm trying to observe and record 100 species, and I've got 92 right now.
Huh.
But of course, the deeper you go into the list, the slower it goes.
Sure. Yeah.
So, but I added a few last week, which was nice. Kentucky warbler. I added an
Oh.
orchard oriole, which is sort of a Baltimore Oriole's tricky cousin.
Okay, there's a cartoon in the making.
And a summer
Baltimore
tanager,
or
which is a lovely red bird. So I saw those last week here. They're all migrants. They're all just passing through on their way north.
Yes, because normally we take migration to be a very positive thing about life development.
That's right.
Unless you're
And they're
Republican, thinking about our own human migration, and then boy, oh boy, they're going to come try to take your jobs or your kids.
and that's one
Really
aspect of
bad
that
thing.
damn wall that he wanted to build is that
Yes,
wildlife migrates across the
totally.
river. I
Oh
mean,
yeah,
it's
and
it's just
it's not just the land walking animals. By the way, we've done to go on our Vocama Good channel. You can watch some videos we have about this and what we recorded when we were there. There's a number of flying things that
yeah,
don't want to fly 30 feet high. They never
I did
do.
not ever think of that.
Yep. And they're like, well, I'm not going up there. I'm a butterfly, man. I can't.
Oh, like butterflies.
There's things. I mean,
Oh,
the people who
I've
study
never
this are just like the terrible impacts of this, of a border wall, is just unmeasurable.
even beyond the human world. Yeah.
Yeah, I mean, just the geological world, and another, just to somebody who doesn't want there to be a wall, I want, I want to stand up and say, uh, Mr. Biden, tear down this wall and use the metal to build, 50 great cities in the open spaces of America. That would actually be great. It's an idea that I was conjuring up riding along the U.S.-Mexico border for 67 days. And it turns out like 6 months ago, Trump comes out and says, yeah, we should start other
Yeah.
great cities. And I'm like, finally, one thing that man is not a total. But one of the things is the land itself and water doesn't want there to be a wall. If
Right.
land and water had an opinion, they'd have an opinion not to have a wall. They keep eroding it and just ripping it out, and it's collapsed. So they've had to add gates. Get a load of this. What did they have to do? Add doors to the wall to let all the water and the debris and everything through because it's being smashed and eroded underneath. Meanwhile, they spend $40 million a mile building a wall. Think about
That's
that.
how much it costs.
Somebody tells you we should build a wall and we don't have enough money for this or that, and migrations are going to cost us too much. How about $40 million for a mile of wall in places where there shouldn't be a wall? Now, not all of it. Some places it's only $12 million a mile, but it gets up to $40 million a mile because what they have to do to build a ridiculous wall with gates in it, and they have to leave Paul, literally, they have to leave the gates open because that's where the water and the debris is going to flow through. So then you say to yourself, why are there holes in the wall? And then they say, well, we just have people watch those. And you're like, well, isn't that then what we should do?
Right.
I mean, it defies all manner of reasonableness.
The reason why it got as far as it did is because of the utter simplicity of the image.
100%.
100%. It is, and that's one of Trump's geniuses, is coming up with these completely like simple to the level of boneheaded ideas, like make America great again. Like that is the simplest, dumbest thing he could ever say, and it works. Build a wall. The image is simple. The message is clear.
Yes, until you think about it, right? It's like love is the answer. Okay.
It's as dumb and in your face as those big Trump signs he puts on his buildings and his airplane and his helicopter.
Well, and he's not the only one. Look, a lot of Democrats supported walls for a long time and still do. I mean, I talk to these people, not Democratic voters, like lawmakers. They also think that walls make sense, and walls do work to do some things. I have them in my house.
Yeah, right.
That's I make a room out of it. They're just not good as border demarcation devices. And they're really bad. And they're really bad for the birds and
butterflies
and the butterflies and all of the things that walk across. It's just it's really quite devastating. Well, we have run from the skies to the waters to the depths of the Minnesota lakes where. Kimberly reminds us that we have the loon here. Do you ever see a loon?
Oh, baby. Oh, yeah. I see them, and every December I go down to the Florida Panhandle to a nature preserve down there, and that's where they spend their winters. Is down.
Yeah, they winter in
Florida
too.
And so I have seen them in Michigan in their full summer regalia, but normally I see them in their winter clothes down here. And the sound is primo.
Yeah, it's a loon call. I would try to do one, but I can't. As a kid, the big thing you tried to do here in Minnesota was to make a loon call. I bet Kimberly could do it. I don't know how to. I can't.
Oh, I was too bad. You do it?
The people who can make a loon call with their hands.
Yeah.
Impressive. I bet there's competitions probably up in northern Minnesota.
Oh, you know that happens.
Loon call business. All right, we have done all the level of things we can see. This is what happens when Dan's not here. We just keep going. You just an hour, 10 minutes.
Run
All
our
right. Well,
yaps.
I hope we got the audio figured out and that worked and people could hear all this stuff. So, thank you, Paul. See you in a couple of weeks,
Sure
buddy.
thing. See ya.
Okay. All right, y'all. See you all. Hey, by the way, we're going to be back we're going to do a little thing today on understanding Title 42 and immigration. So if you're up on these channels, you'll see a few more things. And then tomorrow, we're part of a big action down in Florida, calling out the Christian Nationalist event that's going on at a Trump golf course. So a bunch of things happening on these channels. Keep up with all of it, and head over to votecommonggood.com, see what we're up to. And we're in a big fundraising effort right now. So if you can chip in anything, or if you can give us a lot, it all goes a long way. Because chip in, if you're not golfing, it's a strange little phrase. But if you can give us all the money you have, we would take it and do something good with it, I'm sure. All right. Thanks, everybody. Talk to you soon.